Second derivative tells us what the shape of the curve looks like. Is it curve up or curve down? And an inflection point tells us if it goes concave up, concave down, or vice versa. Last thing the second derivative tells us is it can be used to test whether you have a min or a max. And in some cases, it's a little more useful than the first derivative test. My first worry, though, is that you don't get the two confused. What does the conclusion for the first derivative test by maximum sound like? Give me a maximum test for a first derivative. F has a max at
something because
something
because
F prime positive to negative. That's the first derivative test. Don't lose that. Don't confuse it because you're about to get a second step test, and people tend to get the two mixed up. All right. So if you draw just a little picture, you'll see the basis behind the second derivative test. If at a certain point the derivative is 0, then that means the graph goes flat or there's a horizontal tangent. So I'm saying there's some graph that has a horizontal tangent at C. At that moment, it goes flat, and that's a good candidate for an extremum. Now the second derivative will tell us a little more. If the second derivative is positive there, then it's concave up. Now if you take those two ideas together, flat with concave up, it's got to be a min. There is a min at x equals c. Now, you have to have both pieces of evidence because surely just flat could be a min or a max, or neither, yeah? And furthermore, second derivative positive only, that's any point here. Surely all of those points are second derivative positive, but they're not maxes. So it's or mins. It's the combination of flat and concavity that makes for the min conclusion. So it requires two pieces of evidence. Put that off to the side, please. Requires two pieces of evidence. All right. By the same token, let's say we found a place where the derivative was 0, so the graph is flat at C. But now the second derivative is negative. If the second derivative is negative, the graph is concave down. If you draw a flat spot at C and then add in the concave down, then that must be a max. All right. The second derivative test for extrema then. If there's a point at x, this is what the conclusion looks like, something like this. If you can show that the derivative is 0, the second derivative is negative, then you can conclude there's a min, a max there. And if you can conclude there's flat with concave up, there's a min. Helps to draw a picture or draw a little doodle of the graph. Would you also write in this box, F double test sometimes fails? In that case, use the first derivative test. I'll get a case like that on the back of these notes. I need to add that in. All right? So let's show how this works, okay? So if you go to look at this first example, find the x where relative extrema happen, justifying your conclusions with the second derivative test, not the first derivative test. Make sure that you read the directions carefully. Obviously, if I say on the homework of the test, I want you to prove that you know me, you know the second derivative test, and you say, I don't remember the first second derivative test, that's a problem. You need to ask. Okay, so practice what I ask you to practice. First thing is you need to find where the graph goes flat. So you need to find where the derivative is 0. The derivative is what? Radhika, hit me with the derivative. How? Well done. Okay. Does this factor Aaron?
Yes.
It does. How does it factor, please? Wonderful. X plus 5, x minus 3, therefore zeros are negative 5 and positive 3. Are you all with me so far?
Yep.
Okay, now here's where we start to diverge. So far it's just like we've always been. Now we're not going to do any sign test on the first derivative. I don't care if the first derivative is changed. That's not how the second derivative test works. Now we need to find the second derivative. What is the second derivative? Mr. Garcia, what's the second derivative? Plus 2, I agree. Okay, now again, I want to test, this isn't an interval of second derivative test, like concave up, concave down region. I just want to test at those points what's going on. So you actually put negative 5 into the second derivative, not test around negative 5. Put negative 5 into the second derivative to see if at that point it's concave up or down. I get negative 8 for the second derivative value. Now, I just found, whether you know it or not, two things. I found that at negative 5, the graph goes flat because the derivative was 0, and we just established that the second derivative is negative, implying the curve is concave down. So that's enough to say, oh, there is a max there. The conclusion looks like this. Be clear on your subjects. F has a max at, we're looking for maxes on F, not F prime, not F double, F. F has a max at x equal negative 5 because now two pieces of evidence. Because the first derivative is 0 and the second derivative is negative there. Now notice I didn't say because the first derivative is 0 and F is concave down there. That makes sense, and I agree, but it's not the concavity of F. It's the second derivative test. I just say the second derivative is negative. Understood? Okay. Yes?
So, what if this
Second derivative test is quicker in a lot of ways, and the second derivative is the only way to do some implicit functions. So it's kind of like, first, it's always good to have a second way of doing it, but there are some problems that you can only do by second derivative, and I'll try and get an example on the back.
Can you just sign test and find out if it's actually right?
In some cases, yes, but in some cases, your derivative is actually a function of x and y, and there's no such thing as a two-dimensional sign test. So, yeah. So there are cases where the second derivative is all over. All right? So let's go with the next conclusion. Now we need to test F double at the other critical number 3. You put 3 into F double,
8.
you get 8.
Yep.
If I do a little doodle there, it's flat with concave up, which means at 3 there is a min. Does that kind of jive overall with the shape of a cube, that at the leftmost critical number it's max? Yeah. Okay, so let's conclude. F has a min at x equals 3 because
Prime equals 0.
F prime equals 0 and
Double prime is positive.
F double is positive. Okay? That's what the second derivative test looks like. Try one on your own. Use pre-calculus / algebra 1 graph knowledge as a backup. Where did that go? How we doing?
Superb.
Excellent.
Bailey. Turn around with you.
All right. Are we ready? All right. Sorry. What did you do first?
I did the first derivative test.
Okay, so 2x plus 2, so I'm glad you said first derivative test, you probably didn't need to, but it's always the case the first time that I quiz on this that I get some kind of Frankenstein's monster of a test where somebody says, hey, there's a max because the derivative goes positive to negative and the second derivative is positive. That's not the thing. That's just lots of little bits and things thrown together and you hope it sticks. So it's don't kitchen sink it, right? You're either giving me the first derivative test or the second derivative test. And if you're thinking, if I give you too much information, will you cannot? Yeah, I will. Okay, because you're making me read stuff that's not part of the second derivative test. So please, would you just give me the first derivative or second derivative test, depending on the question, and nothing else?
So we don't say we gave the first derivative and second, it's just you.
You're not, yeah, you're not overachieving. You're underachieving because you don't know the difference to me. Yeah. So would you get x equals -1, yeah?
Yep.
Okay. So now do I do some kind of sign test around -1?
No way.
That's the first derivative test. That's not the question. The second derivative test says find the second derivative.
It's just 2.
It's just 2. That means it's always concave up. Does that make sense? Yeah, it's a parabola. Of course, it's always concave up. So we conclude that f has a min at
X equals 1.
x equals -1 because
F prime equals 0.
and
F double prime is positive.
is positive there. All right. That's about good. Now, would you flip this over? I wanted to get one more example here. The second derivative test fails when
Never.
the second derivative is 0 or the second derivative is undefined at a critical number. So, for example, find any extrema of g of x equal x to the, let's go 3/2. Use second derivative test if possible. Okay, so what do I do first? Actually, should I give you a minute to write that down? Do you have it?
I don't know.
All right, very good. This is where I give you notes to the same thing. But I blew it. I didn't copy the back. Okay. Thank you. Okay, so what do I do first?
Find F for G of prime.
Find G prime. G prime is
3/2 x.
3/2 x to the 1/2.
Or square root of x.
Find, or square root of x, good point. Find where this is 0, technically or undefined for critical numbers. Wouldn't you agree that that is true at x equals 0? Okay, cool. Now if you then go on to the second derivative is 3/4 x to the -1/2, or 3/4 square root of x, yeah? G double at 0 is undefined. That is to say, concavity cannot be determined there. I don't know if it's concave up or concave down. The second derivative is kind of failing me there. Because the second derivative test is undefined, the second derivative test fails. I must go back and use the first derivative test. Okay, so going back and first derivative test, how does the first derivative test then proceed?
Zero in the middle.
Put a 0 in the middle and sign chart the derivative at a
Negative.
who?
But you can't take the square root of a negative.
Let's do O.
Should have done thirds, darn it. Oh well.
Should have done.
That's why I wanted to do 5/3, not 3/2. Okay, shucks. No, there's domain-wise there is nothing there, yeah?
Yeah.
And afterwards it's positive.
Yeah.
So actually, this is a totally different idea we haven't talked about. It's all right. Might as well lay the foundation. So if the graph exists at 0 and then afterwards increases, then what is it? That's a min. Okay, it's an endpoint minimum. At x equals 0. Minimums or endpoints are kind of a different animal. We'll get to in set. 61 maybe. Sorry, it should have been 5/3, but you get the idea. I will gradually get more and more practice here. We'll be good. All right. I want to go over the test, but I need to go over it tomorrow because I still have a person or two to take and the take needs to take it, and we still have 2 sets of questions. Yeah. So I want to get questions knocked out. 48. What questions do you have on 48?
Let me see real quick.
1.
Number 2.
1, 2,
13. Oh, 13.
1, 2, 13,
22.
22. Okay.
Maybe we should do it.
There is no test this week, but you might see a quick, can you do a related rates question? Can you do a definite integral question? Do you know your 6 trig derivative question? All right. Maybe like a 10-minute quiz on Thursday. Okay. Oh, you're not going to study for this. You're just going to show up. So you study for your physics. All right. Would you rather have that Wednesday?
No.
All right. Set 48, number 1. It's just a status check. It's not a big
This was so easy.
48, number 1. Okay, you are making good progress. You have to establish what's varying and what's constant. So, first of all, look at your work. Do you have given this? Now, the last class asked, do I have to really write the word given? The answer is, depends on if you want me to find it or not. If you're saying, will I, when grading, go and find the DBDT without the word given? The answer is no. I will not look for it. If it's not saying given this, guess you won't be getting that point. So do I want you to write the word given? Yes.
Of course, always.
I expect it. Okay? I will not hunt for the given. You need to write, hey, this is given. So what is the given here? The RDT equals positive 1 centimeters per second. I love that you said positive to show it's an increase. Okay? Same goes with the second point. Do you clearly have written what you want and when? Yeah, good question. I'll come to that in a second. That is a given. I'll come back to it. Okay? All right. What do they want and when? Find the rate at which the volume is changing at the instant the base of the cone has radius 24 centimeters, yeah? So, most people do dV/dt well, but now let's talk about the other stuff. They tell you in the first sentence the height remains constant at 10 centimeters. Does that mean the height is always 10?
No.
Yes. Yeah, the height remains constant at 10. You can put 10 in, leave it in, it's always 10. You can feel confident, but that's not varying, so that's cool. What about the other part? It says Find the rate of change in the volume at the instant the radius is 24 centimeters. Does that mean the radius is always 24? Put that in too?
Oh,
No, that's the wind. Okay, radius is not always 24. It's the moment in time they want you to, so do not put that in before your calculus. That's variable. You have to know what is staying constant and you can put it in right away and what isn't. The volume formula for a cone is that, and if you can get it down to two variables, you should. What can I do to get it down to two variables? Yeah, we said that 10 is always the height, so plug that in. Make your life easier before your calculus. Now differentiate with respect to time. If I take the derivative with respect to time on both sides there, I get dv dt is 20 pi over 3 r dr dt, and plug in your stuff and do your thing. dv dt is 20 pi over 3 times 1 times 24, so 160 pi. What are the units on dv dt? Centimeters cubed per second. And it is positive. Which makes sense. Okay, are you down on one?
Yeah.
All right, to me that would be kind of a easier one of these as far as these go. I mean, none of these are really that easy, but it's easier than most. Is two still a question? Yes? Okay, Emma's using a faucet to force water into a spherical balloon. Again, if it's a geometric figure, I don't require the picture, but if you want, you can definitely show there is the radius of the balloon constant when they say find the surface area rate of change when the radius is 7? Does that mean the radius is always 7, or is that the instant? That's the instant. So as far as putting in a picture, do not call that 7, call it r. It's not always 7. What is given and what do they want and when?
dv dt is given.
dv dt is given. dv dt is,
Positive 2 centimeters cubed per second.
okay, and what do they want?
dA dt.
dA dt. Now that makes this one, and when do they want it? When the radius
R
is 7.
equals 7.
Okay, so this is a good question. I can see why you're asking. What makes this question a little harder than the average?
There's no relationship.
Yeah, it's not a direct relationship anyway. So what do we do if there's not a direct relationship between volume and surface area? You could actually make one. You could do a little
That's what I did.
substituting in to get a VA equation. Or in calculus terms, you could use dv dt to find dr dt, and then once you have dr dt, then you can use dA dt. So that's how I will approach this in a kind of a two-step way. I'm going to use the volume to find how the radius is changing. Then I'm going to use the RDT to find how the area is changing. We?
Yep.
Okay, so if I start with the volume equation, 4/3 pi r cubed, then dv dt is 4 pi r squared dr dt, eh?
Yep.
I know dv dt is 2, and the radius is 7. Bless you. That's 4 pi r squared, right? Sorry about that. Okay, so dr dt is 2 over 4 pi times 49, or 1 over 98 pi. Are we cool? I'm not going to worry too much about units on that because that's not my final answer, so don't worry about that. Now surface area. What's the surface area formula for a sphere? 4 pi r squared. Now if I take the derivative on that with respect to time, it's 8 pi r dr dt. Now we have everything we need. 8 pi is constant, the radius is 7, and dr dt is 1 over 98 pi. So I could take 7 into 98 and get 14. And the pi's divide away. 8 and 14 reduced down to 4/7, and what are the units on area change with time? Centimeters squared per second. So that was a good question. It had an indirect relationship. Are you with me?
You're with me now.
Okay, cool. How about 13? Is 13 still
Yep.
with us? Right? 13. All right. 13, is that replacement or book?
That is a
Book.
Okay. Okay, so they tell you that G prime at 2 is 0. G prime,
It's less than 0 when x lies on the vertical from 0 to 2.
and G prime is
It's greater than 0 when x lies on the vertical 2 to 4.
all right. So in terms of graphing this, first of all, don't worry about a vertical. It doesn't really matter if you put your graph above or below the axis. It doesn't matter. We cannot know. This, what do you know about what's going on before 2? If the first derivative is negative, the graph is decreasing. So you should be decreasing up to 2. What does this mean about what's going on at 0?
It's flat.
It's flat. And then what does this mean about going on after 2?
It's increasing.
Increasing. And I think I also said what's going on there, min or max.
Yeah.
And you can see FG has a min. X equal 2 because G prime goes positive to negative. Okay. 22. 22 is a good one. It would help if you knew the graph for this, but you don't, so we'll go without it. But the function is, where'd it go? X squared plus x plus 1 over x for x less than 0 only. Now, just basic rules of math you need to understand. Is it true that if you have a sum in the numerator that it can be split up and truth is maintained?
Yes.
So this, you're saying this is allowed and this is 3 either way?
Yep.
I agree. What about a sum in the denominator? Can you split up a sum in the denominator and truth is
You don't
maintained?
want to break math.
No, you will break math. This should be 1/3, but now you're saying it's 1/2 plus 1 is 3/2. That's not true. You cannot do it. So a sum in the numerator only can be broken up. This, therefore, is the same as x squared over x plus x over x plus 1 over x, or x plus 1 plus 1 over x. Side note here, this is a graph that you'll eventually come to know, but this actually looks like x plus 1, looks like a line, but has a vertical asymptote at 0. So it has a slant asymptote, and the graph looks something like that. Set 80,
Whoa.
set 80, you'll do this. Now, graph or not, knowledge or not, this is what you're looking for. Does it have a max or min on the left side? You don't need to know the graph. You can just kind of fly blind if you're good with your calculus. So we want to now see what's going on the left side. Take the derivative. What is the derivative on the broken up side or part?
1 plus
1 plus 0 plus natural log?
1. No, that would be the integral.
That's the antiderivative. So what's the derivative of x to the negative 1?
Negative x to the negative 2.
Negative x to the negative 2. Or 1 minus 1 over x squared. Still kind of ugly. Let's get a common denominator. This is x squared minus 1 over x squared. which is x minus 1, x plus 1 over x squared. Where is this 0 or undefined? X equals 0, negative 1, and 1. Are those all good critical numbers?
Or wait, one is not. One is not. Zero is not.
0 is not because it's not in the domain of the original function. There's a vertical asymptote. Now, that said, you should include it in your sign test because although it's not a point on the graph, it can be a point where the graph changes behavior. So when you go to do your sign test, you actually should include all three because the derivative could change sign around 0, 2. So if you look at the derivative, say at negative 5, I get negative, negative, and the denominator is squared, so it's positive. Therefore, in the far left side, the derivative is positive, meaning the function is increasing. And negative 1/2, negative, positive, positive, one negative is negative means the function is decreasing. So what's going on at the critical number at negative 1? If the derivative goes positive to negative, there is a max there. The curve, the graph, y, whatever you want to call it, of y has a max at x equal negative 1 because y prime changes positive to negative. There is something going on at 1, but they just said look at the right side only in the problem, so I guess we'll just blow off the one part of it. I think okay. That was 13. What was that? 22. That was 22. So we're done with 48.
Yeah.
Cool. 49. What? Questions on 49? 1. Smiley face, frowny face. Number 1. Oh, you probably weren't able. Did I change 4? I assume I changed 4 or dumped 4 altogether. I probably had to because you didn't know the second derivative test yet.
Oh, yeah, you replaced it.
I replaced it. Good.
3, Miss Crickman.
3. Cool. Any other the replacement problems need work because they're confusing? 4. Let's go over 4, shall we?
This set 49.
No, that's 2. Oh, actually, I just buried this one. Here. Okay, there's the notes.
Thank you. Thank you.
All right, so let's go with 1. 49, number 1 is, you got your cone. I feel like they're trying to mislead you here, shamefully. They say this is 5, this is 10, but they quite cruelly say 5 in the picture here. That is misleading because that fluid is not always 5. So be careful there. What are they giving you here? What did you put for the givens? dV dt, I agree. It's dripping out, so dV dt is negative 1 cubic centimeter per second. Okay? What did you say they want and when? No, they gave me dV. How fast is the depth of the liquid changing? So that's kind of this, isn't this? dH dt, and when do they want it? When the depth is 5? So when h equals 5 centimeters, yeah?
Yeah.
All right, so far I feel like everything's going smoothly. The problem is that when you go to do the volume, it is dependent on 2 variables, or 3 variables altogether, including v, and that's bad. So you should try and find a sub-fact to get rid of. I'll just tell you, you want to get rid of R, so dH dt stays. So what's another relationship between R? Now I'm talking the radius of the fluid. The radius of the fluid is not always 5, nor is the height of the fluid always 5. What's another RH relationship? Yeah, similar triangles. Okay, if you look at the big cup, it's 5 to 10, or the radius is half the height. Well, the fluid will always have to conform to that shape. So the radius will always be half the height, no matter where. So if you throw that in, you get the volume as pi over 3 times h over 2 squared times h. If you square the 2, multiply it by 3, you get pi over 12 h cubed. And that's a much easier equation with which to work. So, now what do I do?
You differentiate with respect to t.
Differentiate with respect to t. So dv dt is pi over 12 times, what's the derivative of h cubed with respect to t? dh squared dh dt. Alright, if I plug in, I know dv dt is -1. I'm going to cancel out a 3, so I have pi over 4. What's h at the instant? 5. And dH dt is what we have to determine. So I'm getting something like -4 over 25 when I take the reciprocal over, right?
Yep.
Sorry, 25 pi. -4 over 25 pi. What are the units on dH dt?
Centimeters per second.
Centimeters per second. Okay, are we cool?
You're cool.
All right. 3. Same equation, find critical numbers, but then use the second derivative test. How are you supposed to do this when you didn't know the second derivative? So I guess now you'll be able to do this, right? Yeah. All right. So this is a good one. Now we can proceed. -2x squared. All right. So the critical numbers are still where the first derivative is 0 or undefined. The first derivative is 4x cubed minus 4x. And if I take out a 4x, then I get difference of squares. And my critical numbers are?
0, -1, and 1.
Okay. And were there any domain restrictions eliminating those, or are they all good to go?
Those are all great.
Are all good to go. Now the second derivative test then says, all right, don't worry about sign testing now. Find the second derivative and test there. So the second derivative is
12x squared minus 4.
12x squared minus 4. F double at 0 is -4. Now graphically, that means at 0 we have a flat spot with concave down, so we conclude that at x equals 0, f has a max because f prime is 0 and
F double prime is negative.
Right? Okay, what about f double at 1? F double at 1 is 12 minus 4, or 8, okay?
Yep.
That means we have flat spot with concave up, because the derivative is 0 and the second derivative is positive. So we say at x equals, actually maybe we can do -1 also while we're at it, just to save you some time. You'll see at -1 it's the same. So let's say both conclusions at the same time. At x equal positive and -1, f has a min, because f prime is 0 and f double prime is positive at those places. Pretty cool?
Yep. We're cool.
Okay, 4. 4. Find any inflection points of.
Oh no, that's the replace.
Yeah, so we need to.
Sorry.
Let's just check your work here. So how do I find inflection points? F changes concavity, so I need to say, does F double change sign, yeah? So you are being given the first derivative, so at least you don't have to start all the way from F. You can just start there and do the second derivative by product rule. First stays the same, derivative of the second is 1. Plus second stays the same, derivative of the first is e to the x. In terms of finding where it changes sign, I need to find where it's 0, but I probably want to clean this up. What's good cleanup work? Pull out an e to the x, leaving you 1 plus x minus 2, or e to the x times x minus 1. So surely this changes sign around x equals 1. Now when I sign test to see if f double changes sign, make sure you're looking at f double, not f prime, f double. So before 1, say at 0, the second derivative is?
Negative.
Negative. And after 1, say at 3, the second derivative is? Positive. So do I have an inflection point at 1?
You
I do. F has an inflection point at x equal 1. Notice it didn't say find the whole point like we typically have to do. It just said at the x in the question. Because f prime, f double prime. Now, that's right. You don't have to be specific about how it changes sign for this. Like the first derivative test, it kind of matters how it changes sign, right? But on this, you just have to say it changes sign somehow. That's all. You follow? Any other questions on 49 for the go to the order? Do we need answers to all the replacements or no? The backside? You want me to put up the answers to the replacements? Okay, yes you do, because you want to know if you did them right or not. Okay, so the second derivative on number 16 is low, be high, minus high, be low, over the square of what's below, so negative y plus x times 2 of x over y squared. Okay, so there's my second derivative. The second derivative at 1 negative 3 then, negative root 3, is negative root 3, let's say minus 1 over negative root 3 over 3. So it would be negative root 3 plus 1 over root 3 over 3. Is that what you're saying?
No, wouldn't the first one be positive root 3?
Yes, it would. You're right. Okay, good call. Thank you. That makes my life easier because we can say this is definitely positive, so the curve is concave up there. At that point, the curve is concave up. Okay, 23 was an addition or replacement. 23, first derivative tells you slope increasing or decreasing, flat, horizontal tangent, tells you so much. What does the sign of the second derivative tell you? Concavity. The function has...
Good morning, Denver Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Paul, do you have Jaguar spirit? Do you want to be on the sidelines to get into the game for free? Do you want to help get the crowd going at our mascot DJ? If you're interested in learning more about this incognito position, talk to Ms. Battaglia. Today, Dartmouth College, private Ivy League research university in Hanover, New Hampshire, will be sparkling or
The first question says, if the first derivative is positive, then f of a must be greater than 6, because it should be increasing.
The Teacher of the Month award.
the
Go to
second
Devlin's
derivative is
homepage, click on
negative,
Teacher of the Month icon found next to the Devlin's press releases
that
section.
means the changes are
Senior high
decreasing,
students. All juniors will be required to counseling this for a college case study with
Right.
a counselor during 7th hour. Today, last name
that
A
implies
through
F
Tone
prime
report
is
counseling,
negative,
and
is
L through M
decreasing,
to room
so the
100.
changes are decreasing.
Tomorrow, last name
First
L
change
through
was
M
6,
counseling,
so the
and
next change
his
will
room
be
to E100.
less than 6.
Junior
So if
high
it changes
students, all
less
take
than
good
6, then the
report
next
for
should be
ICAPS
less than.
during 7th hour. Today, if the first letter of your last name is A through D, please report
If
to
it
the
was
office.
6 and it changes less than 6, then the next one will be less than.
Congratulations to the
Whoa.
police team for placing 5th overall at state and for winning the team sportsmanship award.
Less than 4.
Congratulations to Phoenix Lee, Carter Smith, and Mason Gustafson, and Ben Bowman for getting 3rd place at state. Congratulations to Brandon Pennington for getting 4A Jeffco boys tennis MVP. What an accomplishment and a strong finish on a great season. Go Jags!
Wow, look at you, Pennington.
Congrats, girls softball. The girls had an awesome
26.
Saturday regional beating Northfield and Pueblo West.
Find
This
F
Friday, the
prime.
Lady Jags will be in the Sweet
Find F
16
prime.
state tournament on Friday. Wait, no school? The girls would love to see you on your day off. Coach Perico.
So the
Congratulations.
flat spot is 5-6, yeah?
At the Arapahoe Festival on Saturday. The band scored their highest score in Devlin history at 82. They
So
won three
it's
and also beat all 4A schools.
flat and concave down.
Hey guys, it's time for your daily
So
dance
F has
today.
a.
It's Holly's birthday! Hey, somebody wish her a happy birthday. Oh, you're not Jack. Have a great day.
F double is negative. Alright, so you should have something like a max there, yeah? Alright, and 27, last replacement. F prime is 1/3 x cubed minus x squared plus 1. F double is x squared minus 2x, which has 0, and 2. Okay? And I believe the graph, because it's parabola shaped in essence, the second derivative is going to go positive, negative, positive. So the only stinker is that you have to find the y's. F has inflection points at 0 blank. What? 7, yeah? And at 2 blank, you have to find F at 2, sorry. Because F double changes sign. I will be grading, so make sure you actually found F at 2, so make sure you find F at 2. Something like 16 twelfths minus 8/3 plus 2 plus 7. So negative 4/3 plus 9, or I am almost doing everything for you. You get
Plus
the, isn't it plus 9?
There's minus.
That would be minus 9.
No, wait, no.
Isn't it positive x plus 7?
I made it.
So, 23/3? Alright. There we go. Okay, 48 and 49 are done, and we're caught up. Feels so good to be caught up. So good. We're only caught up to 2 I can sit back. Alrighty. Have a lovely day.
We got a fun sheet tonight.
Fun sheet tonight.